Hello everyone. Today we are going to see something that is related to hybrid electric vehicles, right? Today's topic is series hybrid electric powertrain, and this is very much important. It is available already into the market, and being electric vehicle skill development under the course of GTU, whether it is a minor course or whether it is related to the seventh semester electrical professional course, that is electric hybrid vehicle, this topic is very much important. In the previous videos, we had seen about different architectures of electric vehicle, and today here in this we are going to see about series hybrid electric powertrain. So let us see it. Here on the screen, you can see this the various architecture we had already studied previously, and that is hybrid, series parallel hybrid, and a complex kind of hybrid vehicle system. So basically, when you see the architecture, you can understand that in case of series, there is one transmission method available, that is through electric motors. Okay, and in case of parallel hybrid, we'll have possibilities of two, that is torque coupling and speed coupling method for connecting parallel hybrid. So this is what we'll study in the future coming videos. And then there is a combination of series parallel hybrid and the complex. So let us see today's topic, that is series hybrid powertrain. Okay. So here on the screen again, you can see about the series hybrid. The wheels of the vehicle are being run through the transmission, that is mechanical transmission system, and the mechanical transmission system is coupled with the electric motor. But here in case of series hybrid, the electric motor is having two different resources, that is running through either IC engine or through battery. So, some portion of overall capacity of electric motor can be transmitted using, that means power can be delivered using IC engine, and some may be through battery. So here, especially if we consider the degree of hybridization, that is possible to have, making both the combinations. So what is degree of hybridization? It is basically the ratio of the motor capacity to the total capacity of the vehicle. So here IC engine is connected um, mechanically to the generator. Generally the term comes, that is generator, some people say alternator also, and alternator is connected to the power converter, and the power converter is delivering the electric power to the electric motor. Sometimes here, especially the generator may have a different power converter, and which is again converted to the required DC or AC supply based on the selected electric motor. Battery is also going to deliver the power to the power converters to the electric motor. So nextly, you can see here that the basic structure says the mechanical transmission is happening through the electric motor, which we say as the traction motor, and which is connected to the motor controller. And the motor controller is connected in two ways, that is the series combination, and one is the converter, which is coming from the IC engine and the generator, and other is coming from the battery. So here, especially in the block diagram, you can see the wheels of the electric vehicle that is connected mechanically to traction motor are getting power from IC engine as well as from the battery, and both is possible. So that is what here I want to show you. And now let us see the various modes of operations of series hybrid electric vehicle. Various modes of operation in case of series hybrid electric vehicle is: one is pure electric mode, that is the engine is completely switched off and the vehicle is running only by the batteries. That means the power transmission is done through battery to the converter to the motor controller, and ultimately the vehicle is running. Second mode of operation is a pure engine mode, definitely. So in that case, the battery side is cut off, that means switched off, and the whole power is being transmitted through IC engine to the generator, to the converter, and ultimately to the motor controller, right? So this is what the vehicle traction power supply only comes from the engine generator, while the battery neither supplies nor draw any power from the drivetrain, and that's the pure engine mode. Another and third mode of operation, that is hybrid mode. So the traction power is drawn from both the sides, that is engine, generator, and the battery. And this is how it is possible that the total capacity can be delivered to the traction motor. Okay, so you can understand that the degree of hybridization is possible in this case, that is 100% fully hybrid. That is also possible. Number four is engine traction and battery charging mode. So the engine generator supplies power to charge the batteries and run the vehicle. The fifth one, that is regenerative braking mode. So in this case, the engine generator is turned off, but the traction motor is operated as a generator. And in case of braking, the power generated is used to charge the batteries through the converter. Another operation possible, that is battery charging mode. The traction motor receives no power and the engine generator charges the battery. Right? And the seventh, that is hybrid battery charging mode. So engine generator is supplying power, some of the power to run the vehicle and also to charge the battery. So these are the various modes of operation in. So now let us see about the advantages of series hybrid electric vehicle. That is, first one is electric motors have nearly idle torque speed characteristic. That means it is going to work at the optimum efficiency point, optimum efficiency zone. So they do not need multi-gear transmission, and the construction is going to be simple. Second is, instead of using one motor and a differential gear, two motors may be used, each powering a different wheel. That means a single wheel. Third is, the engine is fully mechanical when decoupled from the driven vehicles, therefore it can be operated at any point on its maximum efficiency. And the fourth is, simple control strategies may be used as a result of the mechanical decoupling provided by the electrical transmission. So compared to other hybrid electric vehicles like parallel, series parallel, and complex, this is going to be the simple. Okay, and other point you may consider based on the power and weight ratio also, and compared to battery electric vehicle, the advantage is over, that is larger range is also available in case of series hybrid compared to EV, right? Okay, now let us see the disadvantages of series hybrid electric vehicle. So on the screen, you can see the disadvantages of series hybrid electric vehicle. The first is the energy from the engine is converted twice. That means two steps of energy conversions are there. That means there are possibly higher losses. Hence, the efficiency compared to other with having comparing the same capacity of power rating of the motor, right? Secondly, is the generator adds additional weight and cost. Fine. So compared to pure IC engine or maybe pure battery operated electric vehicle, the weight and cost is going to be added. Third is the traction motor must be sized to meet maximum requirements since it is the only power plant running the vehicle. Okay, and another disadvantage is the inefficiency of the generator and traction motor adds the losses, and the overall losses are going to be significant, and that is very much important while we consider the operating range or maybe the mileage. So that's all. Thank you very much for watching this series hybrid electric powertrain lecture, and best of luck for the same topic to appear in the GTV examination. Thank you very much. Subscribe the channel if you have not done so that we can keep you up to date. And definitely drop the comment, like video, and motivate us to make more and more videos so that you can come across what is happening in the world related to electric vehicle, smart grid, and power quality issues. Thank you very much.